Kind of a almost idiot level LED project here. My brother and I were both given these lamps by a friend. I don't know if they were a dollar store item at some point or something. It's got a nice low level of brightness for reading at night. Nice little pleasant light. But I never used mine because I knew it would eat up the batteries pretty quick. An incandescent bulb in there. So I didn't really use mine much. In fact, these are the batteries I put in it when I first got it years and years ago. So they're probably pretty tired. Got a nice little switch. I already started taking the head apart so the head's not completely virgin. There's a little piece that covers the bottom here. I've got it exposed already. Little grain of wheat bulb, which I kind of want to recover for other experiments. So obviously I want to change this over to LED. And my brother's really interested in this project too because he does use his lamp a lot and uses a lot of batteries in it, just like I predicted. So he'd be very happy if I could convert his lamp too. So I started looking into this. What I would do, I was going to use a switch, but I think I'm going to go just a real simple approach, just use two LEDs in series. At any rate, I went and characterized these LEDs as well as I could. Got some examples. I found a spot around 3 milliamps that I think would probably be good for a night reader. Give me good long battery life, still enough light to read by. With that 6-volt battery pack, I calculated out a 1.6K resistor. Actually 1 2/3 K resistor. So I'm going to try to put that together, I guess. I've been debating what to do with the two LEDs. Do I put them both in the head? I wasn't going to put one in the base and have the base light up soft, just as a soft ambient light. I've got a 6-volt regulator here, 6 volts across two LEDs, drawing 11 milliamps. So 3 volts, 11 milliamp on each LED. And they're a pretty good brightness at that level. Okay, I've dimmed the lights down a little bit, and I want to see some useful light out of these, but pretty dim. Probably what they are. If it was dark, I could go a lot lower and still see them. This is 2.46 volt. I've got dimly lit LEDs drawing 1 milliamp. I suppose I should explain my thinking a little bit here. I was looking at these different current levels and voltage levels across the LEDs. And these do vary with temperature a little bit when they're on. You know, these current. If you repeat these measurements, they won't come out exactly right. Of course, it depends on the LEDs and all that. But at any rate, you got to take it with a little grain of salt, temperature, and how long the LED's been burning. And it's a cool environment here. It's probably about 65 degrees Fahrenheit. Probably cooler back here actually at this test bench. Probably about 60. So they will warm up and change characteristics a little bit. Anyway, for that 3 milliamp night reader level, I calculated, you know, roughly 2 3/4 volt. So I need to get rid of, and I'm running 2 in series, so that's 2x. So that's how this all came about. And I'm actually going to use like a 1.2K resistor because that's what I found offhand real easily. So it'll be a little bit brighter than that. But I want to keep the current down. I don't want to lose it all across the resistor for nothing either. So that's why I went with 2 in series and 1 resistor. I took these LEDs to the grinder and I ground them in different ways. This one is unaltered, not ground at all, nice forward projecting LED. This one I ground one side of the LED down a little bit, and then the other one did the opposite side. And then the last one on the left there, I ground flat on top for a more diffused look, which it seems to have done. That's the most diffused of them all, at least from this axis. I was really more interested in this axis of what happens, reading at a book on a page or something. And I wanted to see if my edge grinding would help. So the one that's facing down is that one. Yeah, that's the one I'd probably use for the. Well, I think I'll do that then. I'll have did like a 45-degree angle on the LED. You can see that. I guess I'll turn these LEDs off and come back. So that one's flattened a little bit. Didn't flatten it too radically. Probably should have flattened it more to get more of a diffusion out of it. And these two middle ones I did off of one side or the other. See, that one hit the side. This other one hit just the opposite side of it. Kind of hard to see. And the last one unaltered. Well, it's a little too dim at 3 milliamps for comfortable reading. I mean, I can make out the words if I want to try, but nah, made it a little too dim. I don't know if I'll change it or not because I don't really read by it anyway. I want it just for a nightlight, for functioning. Well, I think I do want it to read though. I'm probably going to cut that 1.2K down quite a bit. See where I get. Try to get like 6 milliamp current flow, I guess. I'm also going to put a piece of electrical tape on the head of this thing and blacken out the top of the head. I was looking at the page without that white head in my eye. It'd be a lot easier to see the page. So I guess I'm going back into this little lamp and I'm going to make it brighter in two ways. It's kind of really not worth the trouble I'm putting into this thing and time. Kind of odd they put these little plastic caps over all the screw holes. They really sealed this thing up well, except for this big hole by the thumb thing. And even the the bottom layer on this thing is all enclosed. They didn't put a little cap over that screw hole. But I think one improvement is going to be to make this reflector, this little short metal reflector, longer. I'm just going to put a piece of aluminum foil behind it for the full length. Cut it so it's the same right width so I can slide it in there and make it so it reflects all the way to the tip here. I think that'll help a little bit. And I'm going to tweak the resistor. I'm going to probably put this little variable resistor in. It's about a 6K variable resistor. I'm going to probably put it on the outside of the case. Kind of an ugly way to do it. Such a nicely sealed cabinet. Sacrilege. I guess I have to commit to a location for this. Use my handy dandy hole puncher. So this is what I settled on. The variable control mounted up here. Turn it all the way up. I get a real bright wand light. Turn it down, and the other light starts to come on. Guess I should turn the lights off to get the effect better here. But I think that'll work nicely. Bright when I need it bright. Nightlight when I need it as a nightlight. In between for reading. A little bright for reading, and then all the way bright for having to do something important. I like it. So the circuit is just this. And this pot was like a 6K oddball pot I came up with. 10K would have worked fine there, and a 1K would have worked for the resistor. Or actually, higher even would have been nice, being that I've got it bypassed too. LED at the bottom is the wand, LED at the top is the one in the base. So at its lowest setting now, it's a little bit brighter than it was. That's not its lowest setting, that's its lowest setting. I can almost read at this level. If my eyes were night adjusted, I probably could. And I can crank her up. And then at the highest setting, the ambient light cuts out. So the wand gets all the voltage. And the main purpose here is to have a long battery life at a low setting and a little more when I need it. Comfortable reading, or to find something or to see something in detail. Turn it back down to where I can read, or turn it all the way down for a nightlight type thing. I can't really show you too easily, but I ground the LED at an angle. I also improved the reflector on this so it's easier to see. It reflects better, but it also keeps the light out of your eye when you're looking down through it or over it. But I cut the ground reflector like along this line, if this was the LED. So it aims down a little bit, diffuses a little bit down. Ground that off. There is a shortcoming in this design. And that is, if I've got this control cranked all the way shorted, so this basically becomes a short circuit, well then I've got 6 volts going right to my LED. And these LEDs are rated for continuous duty at 25 milliamps. I have stressed them all the way, towards 100 milliamps or better. They don't really seem to take much damage from it. I wouldn't burn them long term that way. They'd lose brightness so they'd go out. But in short, I'm not too worried about having not included what would be the solution, which would be a safety resistor. So one more resistor to the circuit if I wanted to make sure I never burned it out by leaving the brightness cranked to maximum and putting that full voltage on the LED. Now in practice, the AA cells have a certain equivalent series and resistance anyways. Although it's not quite 28 ohms, I'd need 112 ohms to limit me to 25 milliamps. 6 volts minus the 3.2 volts for the LED leaves me 2.8 volts left over to deal with. 2.8 volts divided by 25 milliamps cranks out 112 ohms, or 28 ohms per battery if I look at the 4 batteries. Probably not that much ESR in those batteries, so I am going to be stressing this LED out when I do crank it that way. If I do crank it all the way full bright, I'm going to be going above the specs of this LED a bit. I'm not too worried about it, I know that going in, but if I wanted to be sure, I was going to give this to somebody else. Actually, I'm probably going to give that lamp to my brother and take his and modify his the same way. So maybe I'll include the safety resistor in this one that I do next, because it won't affect the brightness that much on the otherwise. I used 2 pieces of aluminum foil separated by a piece of paper on the battery contact so I could interrupt the battery and do a current check on it. And we got 11 milliamps the way I got it set right now, but if I crank it to its max, it does get a little bit concerning. 133 milliamps, which is way over what this LED is supposed to tolerate. It's a good CREE LED, they hold up pretty well. So it would be good to have a safety resistor. And only 1.4 milliamps at the lowest setting, which is brighter than it was before. It's actually almost bright enough to read by the lowest setting now.